A very good morning to the August gathering and welcome back to the second day of the International Conference on Innovations and Research in Marine, Electrical and Electronics Engineering 2021. I welcome all the dignitaries and the organizational members on behalf of the Academy of Maritime Education and Training, deemed to be university, and the Department of Electrical and Electronics Engineering. Light shows us the path of future and symbolizes glory, prosperity, and knowledge. We embrace that by lighting the Kutuvilakku to brighten the everyone's future.
Thank you. Ratnapriya madam. I extend my pleasing welcome to Madam T. Sachilata madam, Professor and Dean, Department of Electrical and Electronics Engineering. Welcome, madam. Now I would like to call our Dean madam to give you a welcome address.
Thank you, sir. Respected guest speaker, Dr. Gaurav Shekhar from University of Texas, Dallas, USA. The other keynote speaker, Dr. Tawasik from Thailand. Then other keynote speakers for the other tracks, respected coordinators of this event, respected faculty members, participants from various organizations, my dear students, very good morning to all. Today is the second day of our 2 days international conference on innovations and research in marine electrical and electronics engineering 2021. At this juncture, I would like to extend my gratitude again to our AMAT management, our Vice Chancellor, Registrar, Joint Registrar, and the entire team for giving us the opportunity to conduct this particular 2 days international conference on ICIR MEEE 2021. This conference is being organized in association with the two professional chapters, IEEE as well as Institution of Engineers India. So hope this conference will give fruitful outcome to all the participants as well as students. Let us begin today's session by welcoming all the chief guests as well as participants. I welcome you all. Thank you once again.
Thank you, ma'am, for your warm welcome. And a sincere thanks to Dr. Tavir and Head, King Mongtus University of Technology, Thailand, for joining with us too. We'll now proceed with the technical session. Thank you, dignitaries. Thank you for the participants who have been joining with us. I'm indeed glad to welcome our chief guest speaker, Dr. Gaurav Shekhar, who's the program director and assistant professor in the University of Texas at Dallas, USA. Dr. Gaurav had a successful stint in the IT industry, but his passion for teaching and dedication towards molding intelligent and sensible graduates brought him to the renowned University of Texas at Dallas, USA. He leads the largest business analytics program in the world, and Dr. Gaurav mentors courses such as robotic process automation, digital consulting, and so on. He received many awards and worked in diversified professional organizations. Sir, we are grateful to have you as a keynote speaker for this session. I now request Dr. Gaurav Shekhar to deliver the keynote address.
Thank you so much, and a very good morning to everybody who is joining us for this the day 2 of the conference. And to all our dignitaries and all our guest speakers and professors and industry professionals who have decided to come together for this wonderful conference. I believe that these are landmarks in our journey, whether it is professional or our academic pursuits, because I think our knowledge can only grow when we share it. So I'm very thankful to everybody who decided to be here and share their experiences and knowledge with us. I'm going to allude to something that may not be alien to you, and you would have heard about it, or maybe even you're researching in that area. But again, it's a question that where does the world go from here? You know, we have seen so much advance in technology, and in fact, the curve at which everything is growing and the pace, let me share my screen here and then kind of, yeah, there you go. The pace at which everything is growing is just phenomenal. You know, one of the things that I especially like sometimes is when our students in the school ask for examples of topics that we are teaching them from at least 5 or 10 years ago to see how it has grown, and we have none to share. And the reason is very simple, because the technology did not exist then. So again, the space at which technology is growing and the pace at which the demands of the industry is growing, whether it is, you know, in this case, the maritime industry, but the two races, one is the race for what my needs are as a consumer, and then the race for developing technology that can support those needs. It's at a very critical juncture. And I think we as academia, we as industry have a very significant role to play in order to meet those customer needs at the end of the day. Now, before we talk about robotics or how exactly robotics has grown over the last few years, I mean, it's no longer just physical robots that are helping, but a lot of data is getting consumed. A lot of data is being analyzed. A lot of data is being processed. You know, tons of models are being rerun, and just to process the data to provide the intelligence to these robots to act in an autonomous way. But if you just quickly look into the kind of data that we are talking about, again, it's no longer about the hunch that you have as an experienced professional. Nobody now says that we are going to rely on your hunch or maybe how things have happened in the past, and you being an experienced professional might give us an idea when we have tons of data to prove or disprove our theories, our hypotheses. Now, when we talk about the importance of insights, you know, by 2022, you know, a year from now, businesses are going to steal $1.2 trillion worth of business from their peers who are not invested in using data. Now, when we talk about artificial intelligence, we talk about machine learning, 8 out of the 10 businesses are already adopting it in some shape or form. And by in the next 10 to 12 years, it is going to increase the productivity of businesses by 40%. You know, one of the examples that I like sharing here is just to see how vastly something like AI has grown. So this is from a conversation, you know, from one of my colleagues who used to work at Google. And again, you know, the team that works on AI, they are top-notch researchers, they're top-notch PhDs who work on AI. And so one of their main fellows who would only meet a specific, you know, high-income clients, he was at a meeting, and the clients asked him that how can they really position their business, or what are the kind of combination of keywords that can be used to really make sure that when people search for something related to their business is the top listed entity. To which the surprising response was, we'll have to see how AI behaves here. So in a way, what he alluded was that the AI has grown so advanced that they themselves don't know how it will react to a certain combination. It has a mind of its own. And just thinking about it tells us that, you know, what are the kind of possibilities that we have in that space when we have given a machine a mind of its own, and a mind that is in some ways even better than the human mind. Just to talk about big data, and if we have to talk about big data, I think we need to really step back a few decades. Goes in the 70s and the 80s, when the whole pursuit was all about establishing systems, creating tools that could store data. That was the biggest problem statement of that time. The 90s was more about fine tuning, okay, how these, or optimizing how this data is stored. But then the late 90s, early 2000s, the question was, now we have all this data stored for like 3-4 decades. What do we do with it? Do we have to just leave it the way it is, or can we really use it? And that's where industry leaders who kind of forayed into how exactly data can be used, how you can make better decisions, informed decisions, look at the gray areas, describe what happened in the past, diagnose what happened in the past, and then come up with a very calculated and informed outcome, was what the whole thing was about. And that's where things like big data all started coming in. I mean, again, if you just look at the way from 2016 onwards to now, it has nearly grown eightfold. And everything right now generates data. In fact, in the last 1 year, when the pandemic hit and we all went online, and suddenly the need for being online, or this need to be digital, increased manyfold, which gave a very big boost to online operations, digital data, and how exactly we can really use that data to make better decisions. The traffic has been humongous. There were reports by companies like Zoom and all, that how their demand for data and how their traffic quadruple in every few hours at one point of time, just when people were getting online and being digital. So again, the crux of this is that the demand for data, and at the same time, the traffic, is just going to increase at a very rapid pace, at a pace that will outdo itself every few units of time. Now, when we have all these data centers out there, and we have all the data that is getting collected, even if we decide to delve into that data, we are just touching the tip of the iceberg. We don't even have that capacity to look at 100% of the data that we are generating to make decisions. That is the amount of data that is in front of us, and whether that data is getting stored in data centers, or it is on our personal devices, or wherever we are getting the data. But the point is, we still don't have the capacity to know exactly what the picture is. Several years ago, and this is an example I always like sharing, it doesn't matter how, I'm just taking an example of a tool, Excel. A lot of us use Excel, almost everybody uses Excel. And doesn't matter how much you use Excel, it is a proven fact that no user will ever use more than 15% of the capabilities that Excel has. And that is just a tool that we're talking about, and the features that are available. Thinking on the same lines, if we look at the kind of data we are generating and the kind of data we are using, we're using nothing as compared to what we are storing. And this is, again, is a big question with organizations, because millions of dollars is being spent on archiving such data. But from a usage standpoint, it's a very underutilized resource. So the question that it begs is, am I delving enough into my data to come up with insights? Or is it just a smoke screen on which we're blowing air? Edge analytics, again, is something that is kind of picked up a lot, because you want to know what other areas are from which you can pick up data and make decisions. For example, let's say there's a doorknob. Okay, you go and you turn the doorknob, open the door, you get inside the building. Can that doorknob be used for me to gather the temperature of people who are getting inside the building? Can I make an assumption whether people who are getting into the building, are they on an average having fever, or are they feeling fine, or what is it all about? A lot of different devices, and especially things like Internet of Things, has given a shot in the arm to things like edge analytics, because now literally every device that are out there that can be connected to the internet is becoming a source of data. is becoming a mini database that can be uh, explored, that can be looked into to aid either your first analysis when it comes to decision making, or just helping you with a secondary type of analysis with let's say you have your data stored in your data centers, but on top of it you have these mini databases that are helping you out with just reinforcing whether your analysis is correct or not. And it doesn't matter what industry it is. You think about a traditional industry that did not use computers, oil and natural gas, for example, you will find a lot of analytics, a lot of robotics, a lot of automation that is being used. Automated drilling, automated scoping. When people look for oil blocks, they're not just sending out people now, and there are just like you have drones, you have automated vessels that are going underwater to do these explorations. And it is only possible because of the humongous amount of data that is collected and the kind of models that are being run, that you're able to predict with a lot of accuracy and precision where your oil blocks are, as just an example there. Conversational AI is something that is picking up rapidly, because at the end of the day, you need an interface that can be used to talk to your to the different interfaces that are, to the different tools that are out there. Can we somehow replicate a human conversation, either through text or through voice, that can simply connect to a system and then converse with you? And again, this conversation is not something which is pre-stored, but this is a conversation that the chatbot develops with you. There was a time, and it still is, most of the chatbots that are created right now are trained on specific questions and responses. You ask them a certain thing and they'll give you a certain response. But with conversational AI, it goes a step ahead, where it develops conversation intelligently with you. For example, you say that, let's say the chatbot, the question is, what is the vessel on which you would like to send the container? And you say, I like pizza. Now, a regular chatbot might respond back saying that, I don't know what you're talking about. What is the vessel on which you would send the container? It'll repeat that question. In the case of conversational AI, the response would be, well, I know you like pizza and it's a good thing, and we can definitely have a slice of pizza later, but right now I want to know, what vessel are you going to use to send your container? See, it's more like a conversation rather than just going with a fixated amount of sentences, phrases that is being used for your communication. And it learns from the communication. It not only learns, but it perfects its future communication as well. And in a way, it tries to just mimic a human being. If you have heard about the Turing test, it says that the Turing test, the simplest way to describe it is that if you're talking to a machine and the machine responds to you and you are not able to differentiate whether it's a human being or a machine, that machine has passed the Turing test. Conversational AI somewhere is, I would not call it the silver bullet, but yes, in that way, it tries to create systems and machines that can be very compliant with what the Turing test is all about. Now, when we talk about robotics, even before robotics, the brain, the intelligence that those robots have is based on some kind of data and some kind of analytics that's happening on it. That analytics is the source of the intelligence that these robots have. And when we are talking about the convergence of AI and Internet of Things and how exactly connecting these different devices, these different ships, vessels, etc., can yield to the intelligence, some of the core top things that we have to think about are these four that are listed in front of you. You have your data and you want to know what exactly happened with it. That's descriptive analytics. Diagnostic analytics is more about, okay, something happened, but why did it happen? You're doing a diagnosis on that. Based on your historical data, there are predictions for the future, and that is part of predictive analytics. And then, of course, the golden question, what do I do? What do you recommend? I can tell you a million things, but at the end of the day, your question will be, all that is good, thank you, but what should I be worrying about, or what should I do next? What's my next steps? That's all about prescriptive analytics. And that's what, towards the end, the rest of the three kind of come together to help you with the prescription as to what is the recommended action. But if you ask yourself a question, okay, AI is good, all this big data and everything that we're doing around is good, but how is it going to really change this shipping industry? Is it going to really change the way my ships move? Or is it going to change the way the vessels, all the operations on the vessels happen? How is it really going to make any shift in the industry per se? Now, the first thing that comes to mind is Internet of Things. And again, with every year, it's an exponential curve in terms of the number of devices that are getting added through Internet of Things. How you are connecting these devices, and then all these devices have a very unique role in the grand scheme of things. By 2023, in less than 2 years from now, they're expected to grow to about 30 billion different devices that are connected. It could be a small device like a scanner to the mainframe that's on a shipping vessel. Now, the key here is that you are capturing all this data, you are storing this data, you're provisioning this data, but how quickly can you get actions out of this data that is in front of you? And we are talking about petabytes of data. Petabytes is like 100,000 terabytes. Terapeta, yes. I sometimes get confused with that, but yes, about 10 to the power 18 is what we're talking about here. Now, when we talk about ship owners or companies that own ships, for them, one very thrilling opportunity is in the shape of autonomous ships. Or how can you establish remote command centers that can literally help the ship do everything that is required to be done remotely. Now, there are self-steering vessels that we talk about, and there is that are kind of using the same technology, the assisted driving technology that you see in driverless cars. And how do they really function well is, see, on a street when a car is driving, for it, maybe the control that you have on the car is much easier. Why? Because the road doesn't move, the street doesn't move. But when you're talking about having a vessel in the water, there is an additional overhead of, the water currents. And really, to have a self-steering vessel, what you require is that how does the movement of the vessel, how can you collect a stream of data, a strong stream of data that has a very strong uplink so that there's no delays, and it quickly calculates decisions, actions, and sends it back to the ship and helps you do that. So again, it's a thrilling possibility, but it comes with its own challenges and its own conflicts. And again, it's a growing area. So every year, every couple of years, when you look at the technology, it has grown immensely. And honestly, in the way things are moving, this is the way forward. Now, one of the things that has always plagued the maritime industry is the slowness in adoption of technology. And even though AI is emerging, AI is fastly changing, what I feel is by the time a certain technology is adopted, it could be possible that, depending on who it is, you have, players like Maersk and all, who are kind of ahead of everything, them as opposed to another company that might be slow at adopting it, that might create challenges for some of these companies, because again, the glacial nature of this whole industry slows the adoption. And because it slows the adoption, by the time it is adopted, maybe the technology has progressed, maybe the consumer needs have changed. So that is something that balance between the speed at which things are adopted and the need is going to be very critical here. Now, another thing is, maritime operations need to be extremely optimized. And things like the last nautical mile efficiencies, like vehicle precision operations, ETAs, and fine-tuning the container routing, etc., are also going to make a lot of difference. And AI is going to augment it. Even a small fraction of savings can result into millions and millions of dollars of savings, whether it is time, whether it is the way you do your operations, whether it is just business process orchestration and re-orchestration, re-engineering. See, AI implementation, again, at the end of the day, it uses the same data to constantly refine its processes. And again, the first sentence is very important here, because one is establishing a process. The next thing is, how do you make sure that these processes are refined? Now, I would say technology also presents a problem where it introduces a greed to just implement technology without knowing whether it is the right technology to implement. For example, automation. It's a lovely thing. Everybody wants to add automation. But the question it begs is, are you fit for automation? Or are your processes fit for automation? Now, one of the things that I teach my students in, because I teach a robotic process automation class, and I also teach something called IT infrastructure language, which is a framework, the best framework when it comes to IT and service operations, is a good candidate for automation is a process that has reached its pinnacle in terms of maturity. If you have a process that cannot be further fine-tuned, then that's the perfect candidate for you to go ahead and optimize it, automate it. And the same thing happens here as well, that when AI implementation is there and you're getting data streams back, it is helping you make more decisions, it is helping you learn, and it is helping you refine those processes. Now, though the goal is to reduce the decision making, another goal is to reach a point where the process matures. The process matures, the minute it matures, it's all just the same set of instructions that have to be repeated now. So again, the more you automate, the better it is for your operations, because you can move on to something else that requires human intervention. Now, cost reductions are a low-hanging fruit by incorporating AI. And one of the things that, and we'll talk about it, is, some of the issues that occur due to human presence, like fatigue, like degrading performance, it's all elevated by AI. Because when was the last time a machine got sick? Or when was the last time a machine did not follow the instructions over and over again? When machines break down, something breaks down, whether it's their input or their output. But it's not like that a machine that's running just suddenly out of nowhere will start showing degrading performance. And we're talking about software here, not the actual machines. Who doesn't remember this? This was the reason why 10% of the traffic and billions of dollars, millions of dollars per hour were being lost in the month of March. Just because a vessel steered in a different direction and cut the rest of the world off. Now, I'm sure that in your place, you may have thought about this as a perfect case as to what could have been done to avoid this. Yes, there are some natural reasons that could have, you have no control over. But when this was swerving, let's say, or when it was about to hit, the side, of the Suez Canal, and it was, for hours and hours nonstop, dirt was being dug out to just move it a little bit, just a tiny bit, so that it can be steered back into the canal. I mean, a lot of things could have been done if there was some way of knowing that the kind of winds, the currents, and whatever caused it to turn in this direction could have been averted. If that calculation was available well ahead of time, and what exactly was needed to undo what we saw, could have saved us a lot of time. And that's where your robotics, your decision making really comes in with data. Imagine having rotors in the ship that moved based on the current that it was experiencing, whether it is wind currents or whether it is water currents, whatever it is, so that an anti-effect was generated that it could have made sure that the vessel stayed straight. A counter effect. And it's not something that needed, lots of a very expensive infrastructure to do this, but the right tools to even do this on the ship to help in terms of creating that counter effect could have been a possible solution to this. It wouldn't have happened. It would not have strayed the way it strayed. And right now, there are vessels that are kind of working on our solutions that can help create that counter effect onto ships and all, so that such kind of thing doesn't happen again. See, every company has a risk appetite. And the minute your risk appetite, your risk and your losses go beyond a certain percentage, then you're absolutely making no money. And nobody wants to be in that position. 10%. 10% is a big number. When you're talking about billions of dollars, 10% is a big number. Now, McKinsey says that the year-over-year adoption of AI is going to be about 25% over the next few years. And AI strategy in transportation and logistics section, is going to have profit margins of more than 5%, which, looking at the numbers, is definitely a huge amount that we're talking about here. Autonomous ships, again, is another thing that is everybody's favorite topic right now. This image is from a ferry called Falco, and it used ship intelligence technologies of Rolls-Royce to navigate autonomously. Now, this trip was in Finland between two ports there, and the return journey of this vessel was completed under remote control. Now, during this demonstration, Falco had carried around 80 guests, and the autonomous ship successfully detected several objects using technologies such as sensor fusion and AI to avoid collision. Moreover, it displayed its automatic berthing with its automatic navigation system without any human intervention. This was a major news. But the question is, why do you want to prefer autonomous ships? Now, it's no secret that autonomy and AI increase efficiency and relieve humans from unsafe and redundant tasks. See, the key word there is redundant, which means that you have reached a point of maturity that you don't need to change your process. According to the study, more than 75% of maritime accidents are caused due to human errors. Autonomous ships, again, would help to reduce the dependency on humans, which could make mistakes due to fatigue or bad judgment, as I just mentioned a few minutes ago. And again, the assistance of AI algorithm can also help the crew members to make well-informed decisions. On the other hand, programmed ships would be trained to tackle every possible obstacle without rest, making oceans safer than ever. Now, apart from this, the autonomy also reduces personnel and auxiliary costs during shipping. Roughly 30% of the budget in a is set aside for crew-related activities. In fact, there's a study that was published by MUN, Maritime Unmanned Navigation through Intelligence and Networks, and it estimated saving on more than 7 million over a period of 25 years for every autonomous vessel in terms of crew supply, salaries, fuel consumption, etc. Now, AI, automation, robotics, all that, it seems exciting, but what are the challenges? Now, although safety is one of the major reasons why the industry is embracing autonomous ships, but it's a daunting task to navigate the enormous size of the ship in congested waters. There's a lot of testing that is required before the ship starts its voyage. In fact, many believe that AI and other automated technologies would be used to reduce the repetitive tasks. On the contrary, along with the ensuring the safety of the ships, it is imperative to really discuss regulations of shared water. The traditional laws were created assuming that there would always be crew on board. Those laws always expect people to be on board. And there would be a drastic number of changes required in the laws to consider AI, as the captain of the ship. And it's not an impossible thing that the entire ship will have 0 humans present on it. Now, we talked about some barriers, but there are some other barriers as well. And some of the key obstacles are data integration, for example, trust issues, time and energy limitations, and shortage of talent for specific skills. So we talk about analytics, but one of the biggest problems that is plaguing the analytics world is we don't have qualified professionals who can do analytics. Why? Because the need grew at a pace which was much, much faster than the pace at which we train people. Poor quality of data. Let's say that your devices that are connected, they end up creating garbage data for you, data that cannot be really used for your models, and it cannot be used for decision making. And it's just corrupted. It's not the best data that is available to you, will hinder your ability to make decisions. Again, your decision and your insights are as good as the quality of your data that you get. Further, the quality of data would lack reliable information across the supply chain. You need accurate, you need solid data, you need data that is reliable, and you can believe in that data. Because even if there is a small divergence of, let's say, 2%, the compounding effect of that divergence can be so huge that can lead to a lot of issues. Now, another thing with AI implementation is it's the fear of job replacement. And I often talk about how AI or use of automation does not necessarily kill jobs. In fact, what it does is jobs that have to be repeated and that have to be done in bigger numbers, you simply put automation on that, you put your robots on that, and you leave stuff that really requires thinking, that are new challenges, because your new challenges will not stop happening. It's not like that your consumers will never have newer needs. And one of the greatest ways to navigate around this is training. I go by this thing called learning, unlearning, and relearning. Learning new things, unlearning some of the things that you learned in the past that are not needed in the same way, and relearning them the way they fit the current landscape. Another, digitization or digital transformation is another thing that is going to be a barrier. And why I call it a barrier is because, when you talk about digital transformation, it's just not about just getting computers and machines and then you're like, what, we are now digital. It's not like that. Digital transformation really requires things like culture change. It requires training of people. It requires people trusting the systems. It's about using digital methods to do your same business that was done using traditional methods. It's just not getting a new machine and okay, you know what, now we are digital, it's a transformation. You might end up creating more roadblocks, more bottlenecks, just because your workforce is not trained enough to do what it is required to do. Another thing with artificial intelligence is, now again, like any other buzzword in the industry, everybody likes adopting it. Very few have a clear strategy. What are the risks that you are introducing by adding AI or related elements? Is there a step-by-step process? A clear strategy really is required to help you navigate it. Advantages is, first of all, you have advanced analytics. Your decisions are now more data centered rather than just somebody's hunch. You have automated equipment. Imagine unloading the whole ship using just robotic arms. Or how packages, I'm sure you may have seen videos where they show how packages go around warehouses in Amazon's warehouses. The same way, those robots, crawling around and unloading a ship, a container, taking a container all apart, is what we are looking in the future. Automated equipment. We just talked about how berthing and docking was done without human intervention, that kind of stuff. There could be improved safety. You can have lesser incidents with AI. Your AI can actually detect and grow wherever it feels that there are security lapses. Because at the end of the day, if your data is not secured, then you're prone to all sorts of issues. But AI can learn and be intelligent enough to detect attacks even before they happen. Another thing is things like route optimization. As I just mentioned about that container ship in the Suez Canal, think about route optimization, because now you have enough data to make those decisions quickly. Just the way we use GPS for normal travel. Imagine the ships having those capabilities. Why? Because it's able to gather the data streams and make quick decisions. Performance forecasting, the speed at which and the power you're able to forecast based on the data that is getting collected, that let's say the speed at which the wear and tear is happening, or the speed at which the events are happening and things are changing. I can just predict it based on my data that is getting collected. Now, there are pros and cons. You get advanced analytics, performance forecasting, cost reduction, optimizing maintenance. But the cons is, lack of stable information. Why? Because if you have poor quality data, you have lack of stable information. You have fear of job replacement. Why? Because your strategy was more about digitizing things rather than restructuring your workforce around AI and related things. Lack of clear strategy. And remember, at the end of the day, when you transform your business, it's not a simple software that you just installed and boom, everything changes. Getting used to this transformed business itself can take a lot of time. Some examples, for example, Hitachi is, the goal for it is to cut fuel consumption. And what they have done is they have partnered with Stena Line, which is one of the largest shipping companies in Europe. They're using methods, they're using AI to reduce fuel consumption and become an essential tool in the company's effort to minimize environmental impact. Floating a ship in water is a costly affair, not only for the company in terms of the money spent, but also from an environmental standpoint. So AI helps there. Your shipping network operations. So OOCL has teamed up with Microsoft Research to use Microsoft's models for shipping network operations. Wärtsilä is, again, another example where it is establishing a connected supply chain, which is cloud-based. Everything that they're doing is connected to the cloud. They have equipment, they have different devices that are connected, they transmit, they talk to each other, and they send all the data into the cloud, where they have their models residing, and they have their infrastructure residing that can quickly help with decision making. You know, another thing is when you're mining data, and data mining is your process through which you are going to figure out what's happening with your data. I mean, things like energy management, fuel consumption, emission, monitoring the health, route optimization, even with what's going on with your crew and all, mental health and all those kind of things. There are multiple ways through which you can leverage AI. There is a concept of a digital twin, where what you can do is you can replicate a ship and create a digital twin where you are simulating everything that's happening on a ship. So what you do is you run your models on this twin, and then accordingly send data and parameters that can be adopted by the actual ship for decision making purposes. I mean, I feel this is a very niche way to make your ship smarter with its operations and the way things are working with it. Smart vessels, you may have heard about it. And again, one of the things about smart vessels is the usage of these hundreds of indicators, data devices that use either different concepts of IoT or things like edge analytics and all, to really come up with, okay, what do they need to do? According to Nautic Expo, the industry is going to grow to $205 billion by 2023. And really, AI is the beacon of the future when it comes to the industry. So a lot of exciting things in this area. And again, a lot of you, since you're part of the industry, you're right at the beginning of something big with this industry when it comes to using robotics or using AI automation and related things, big data analytics with the marine industry. But again, this is a very interesting topic. And again, my email address, my contact details are here. You can even hit me on LinkedIn. But if you want to connect and maybe discuss this further or maybe work on something, I mean, I'll be more than happy to take this up with you.